Hello class, welcome to this video on the 11.1, so areas of quadrilaterals. So our essential question is how can we calculate areas of special quadrilaterals and solve problems. Okay, so how can we calculate areas of special quadrilaterals and use them to solve problems? So first, we're going to look at the parallelogram, and in order to calculate the area of a parallelogram, you have to take the base and multiply it by the height. Remember that in a parallelogram, the base and the height have to be at a right angle to each other. So base and height must be perpendicular. Okay, so base B and height H have to be are perpendicular. Okay, so base, if you take, according to the formula here, the area of a parallelogram is just base times height. Okay, so this is the formula. Another way that you can do it is by using something called the area addition postulate. The area addition postulate states that I can take a parallelogram and break it up into different parts. So I can take this triangle part, and then I can take this rectangular part and use it to get the area of the parallelogram. So for example, if I have this as the area, so for example, if I have a parallelogram like this, right? Well, if I want to get this formula for the area, well, I can just take this triangle right here, and I can transfer it over to the here, right? And so if I do that, I get a rectangle, right? So then I get this rectangle right here. And we know that the area of a rectangle is base times height, right? And so that's how we get the formula here, okay? And that's the area addition postulate. We can take areas and move them around and then add them together. Okay. All right. So in any case, we just use this formula for a parallelogram. Now, so for example, 1, it says, remember we have, so we're given that the base is 23 feet from there to there. We are not given the height. The height is this. That's the height of that parallelogram. So we're not given the height. We're given 7 feet and then 25 feet. So if I were to look at this triangle right here, that is I got a right triangle. And so we're going to need to use Pythagorean theorem in order to get the height of that triangle. Okay, so I wasn't sure if I mentioned this already in the video, but so we're not given h, right? And in order to solve for h, we need to use this right triangle. And so we need to use Pythagorean theorem, a squared plus b squared equals c squared. So we got h squared plus 7 squared equals 25 squared. Okay, so we have to use that, and then we can use the area equals base times height, this formula here. Okay. All right, so using the Pythagorean theorem, we got, let's show our work over here. So we got h squared plus 7 squared equals 25 squared. Then we need to subtract 7 squared on both sides. So I'm going to do 25 squared minus 7 squared. And then I have to do the square root. So I'm going to do the square root of both sides. And so that's going to give me h equals square root 25 times 25 minus 7 times 7, which is square root of, we got 625 minus 49. Okay, so you get 574, or 76 rather, and then the square root of that is 24. So h has to be 24. All right, so now we know that this is 24, so we can do base times height. So we can do, so we can do the base, which is 23. So we got 23 times 24, which is 552. Okay, so it takes care of that problem. So go ahead and do the check and practice this problem. Okay, all right, so hopefully you tried the problem out. We got our base here, which is 21, and then we got our height, which we need to find by using the Pythagorean theorem. Okay, so if I use the Pythagorean theorem there, I get h squared plus 8 squared equals 17 squared. So I'm going to take the square root and then subtract the 8 squared on both sides. So we got 17 squared minus 8 squared. Okay, and we got 17 times 17, which should be 289. I will double check that real quick. And then it's minus 64. All right, and then we're gonna subtract those and we get 225. And the square root of 225 is 15. So we know the height is 15. And so now we could do the area, which is base times height. Okay, so then the area is base times height. And so we get 315. Remember the units of area are square units, so centimeters squared. The answer is A. All right, so now example 2, we're going to find the area of a parallelogram in which we need to find the height using special right triangles. Now for this example, we have to use special right triangles, and we have not done special right triangles so far in the year. This is chapter 9 is special right triangles, and technically we're incorporating chapter 11 into chapter 7, and therefore we haven't done special right triangles. But it's okay. We can quickly teach you how special right triangles work, and then we can use it in this problem. And then we can do a more in-depth lesson when we get to chapter 9. Okay, so in this example, we are not given the height, but we're given this right triangle. And this is a special right triangle known as a 45-45-90 triangle. Okay, so for this triangle right here, let's draw a nice big triangle. So there are two special right triangles of which you want to be aware. There's the 45-45-90 triangle, in which case the sides are the same. And so if this side is x, this side is x right here, and this side is going to be x times square root of 2. Okay, it's just something that you need to know. It's a special right triangle. It's a 45-45-90 triangle. The other special right triangle is the 30-60-90 triangle. And the 30-60-90 triangle looks as follows. It's x square root of 3, and then 2x. And that's how the 30-60-90 triangle works, all right? Just something that you got to know. In fact, they give you these in your formula sheet, in the geometry formula sheet. So it's not like you have to memorize them because they give it to you there. But we just have to know how to use it. So notice that in a 45-45-90 triangle, the two sides are the same. And so if this side is 9, right, then this side has to be 9, and therefore h is 9. Okay, so we know that h is 9 yards. And then we can just multiply them. We got 17 times 9, which gives us our answer. So we get 17 times 9. We got 9 times 7, 63. So it's going to be 153 square yards. And that's it. Now for the check, you can go ahead and you're going to need to use the definition or the 30-60-90 triangle for that. So we can do that over here. So for the 30-60-90 triangle, if I use this on the left, then I have to realize that, okay, well, the 30-degree side is here, and therefore, remember, we want to find the height here, which is next to the 30-degree angle. Is between the 30-degree angle and the 90-degree angle. All right, and so we're looking for this right here, right? And so we know that, okay, well, we know that this is equal to, this is x in my picture because it's next to the 60-degree angle, right? Because of this 30, this is 60. And h is equal to x square root of 3 in my picture, okay? Because it's next to the 30. So this is x square root of 3. But what's x? X is 12, right? And so this has to be 12 square root of 3. if I compare those two pictures. All right, so now we can find the area. So the area is base times height. So area is base times height. This is my base is 32. I got 32 times 12 square root of 3. And then 32 times 2, we could just do that over here. Or 32 times 12. So we get 384 square root of 3. And we don't have to do anything with the square root of 3. We can just leave it like that. So meters squared. We can also do that as a decimal. So let's see. You have two potential ways that you can write the answer. And yeah, so I get 665.1 square meters. Okay, but either way, you can do the exact answer or you can do the rounded answer. Either way, either one of those is correct. Okay, so let's talk about trapezoids. So we talked about the parallelogram, which is base times height, and then sometimes you have to find the height. So now for the trapezoid, the way you get the trapezoid is you can think of the trapezoid as combining two trapezoids, right? So if you take this trapezoid and you combine it with another trapezoid where you have something like looks like this, right? So that's two trapezoids, trapezoid 1 and trapezoid 2. That's what you see down here, okay? And so notice that that forms a parallelogram, right? And so you can do, in order to get the area, well, we just do base times height, right? So it's the base. So in this case, this is the base, and then the height is given by that, right? That's the height h. So that's how you can get the area of a trapezoid. But then remember that we only want the area of this blue part, and so we could just cut it in half. So if you don't fully understand that, it's not a big deal because they give you the formula for the area of a trapezoid in your formula sheet. And so you can use it. This is the formula. All right. It's just add the two bases. So you add these two bases, then you multiply the height and then divide that by 2. This should say h for height. Okay. So let's show you how to do that. So example 3, we have the area, area of trapezoid. So Andrea needs enough mulch to cover the garden she planted in a raised bed construction in the shape of a trapezoid. If one bag of mulch covers 12 square feet at the desired depth, how many bags of mulch does she need to buy? So first we need to find the area of the trapezoid. And so let me draw the trapezoid so you can kind of see that. So this is 8 and this is 1.5. And they gave us the height, which is at a right angle, is 7 feet. Okay, so remember the area of a trapezoid is 1/2 times height times base 1 plus base 2. So this is your base 1, this is your base 2. So you can do 7 plus, or 1.5 plus 8, and then multiply by 7, and then divide by 2. This is my height, is 7. Okay, so that's what we do in this problem, all right? So we got 8 plus 1.5 times 7, divide that by 2. And let's do that on the calculator. So we just got to do, well, we know that 8 plus 1.5 is 9.5. So we can do 7 times 9.5 divided by 2. And we get 33.25 square feet. Okay, number 2, calculate the number of bags you needed. So use unit analysis to determine how many bags of mulch Andrea should buy. Well, it says here 1 bag of mulch covers 12 square feet for every bag. All right, and so if we have 32.25 square feet and each bag covers 12 square feet, then we just have to divide this by 12 square feet, and that tells us how many bags, right? So we're going to do 32.25, divide that by 12 feet. Okay, so 12 cubic feet, or square feet, sorry. And so that gives us about 2.77 bags. And so we're going to round it up so there's enough mulch, right? Because you know it'd be weird to just buy 2.77 bags. So we're going to need to buy 3 bags in order to cover the garden safely. Okay, all right, so go ahead and pause the video so you can do the check. All right, so let's look at the check here. Miguel wants to cover the top of his desk with butcher paper before working on a project for his arts class. If one sheet of butcher paper covers a square meter of workspace, how many sheets will Miguel need? Okay, so this is a trapezoid, right? So this is my base 1, this is my base 2, this is my height. So we got area is 1/2 height base 1 plus base 2. We got 1/2 times 0.9 times base 1 plus base 2. And we got base 1 plus base 2, that's just 3. And so we just got to do 3 times 0.9 divided by 2. So we get 1.35 square meters. And it says one sheet of butcher paper covers a square meter, right? So according to what they're saying. So that means we're going to need to take, that means if each sheet is 1 square meter, then that means we need 1.35 sheets of butcher paper, right? And so in order to cover it safely, we would need 2 sheets, right? All right, so we have an area of 1.35 square meters, but each square meter is a sheet, and therefore we need at least 2 sheets to cover the butcher paper, to cover the table with the butcher paper. All right, so let's look at example 4. Use right triangles to find the area of a trapezoid. So we're going to continue with the trapezoid, but this time we're going to need to, we're not given the height of the trapezoid, and therefore we need to find the height. So here, notice that they don't give us the height, and so we need to look for that. And so we're going to divide that into 2 pieces. So notice that we have a height there and we have a height here, and that's what they do in this picture here. And so notice that if this is 2, then that means from here to here is 2, which means that this has to be, if you think about it, this has to be 1 from here to here, and this has to be, and it has to be 1 from here to here. Okay, and if you think about it, that makes sense because 2 plus 1 plus 1, right? And so we know that x has to be 1 centimeter. Okay, so we know that the length of this base here is 1 centimeter, and we got ourselves a right triangle. And so we want to use Pythagorean theorem to get that right triangle, to get the height. Okay, so in that case, it's going to be a squared plus b squared equals c squared. And so you subtract 1 squared on both sides and then take the square root. So we got 3 times 3 is 9, and then 9 minus 1 is 8. So we got square root of 8. Okay, and that's what they have here on the steps. So we got a squared plus b squared equals c squared, 1 squared plus h squared equals 3 squared. And that gives us our work there. Then we're going to find the area. So we just found h, and we know that the we know the base 1. And then we know that this is base 1, and then this is base 2, right? The 4 centimeters and then the 2 centimeters. So we're going to plug that into the formula. So we get base 1. Yeah, let me just write it out over here. So the area is 1/2 h times base 1 plus base 2, and which we know the height was square root of 8 because we just found it over here. And then the base 1 was 2, and then base 2 is 4. Okay, so that's what they have over here. So we just got to do that on the calculator. And we get 8.49 square centimeters. All right, go ahead and do the problem below just to make sure you get it. Okay, so let's find the area of the trapezoid. So again, this is height, and we need to use, we need to look at this right triangle. So we're going to use Pythagorean theorem. So we get 1/4 squared plus h squared equals, and then if this is 2.5 feet, then this is 2.5 feet, equals So we're going to convert the 2.5 to 2.5, and actually we're going to convert the 1/4 to 0.25. That's going to make things easier. So I'm going to just do 0.25 squared plus h squared, and then we're just going to convert this to 2.5, 2.5. Okay, so 2.5 squared. And so we can take the square root and then move the 0.25 squared to the other side. All right, and then we're just going to do this calculation on. We're just doing this on the calculator. Okay, and you get about 2.49 feet. And so now we know that we can find the area of the trapezoid. So the area of the trapezoid is 1/2 height, base 1 plus base 2. So we have 1/2 times the height. Now we know that the height is what we just found, 2.49. And then we got base 1. So this is base 1, and then this is base 2. So base 2, remember, is 0.25 plus 0.25 plus 1.5, because remember this is 1.5 from here to here, right? Because that's the base 1. So base 1 is 1.5 or 1.5, and then base 2 is 1.5 plus 0.25 plus 0.25, which is just 2. Okay, so let me write that out here. So base 1 is 1.5. Base 2 is 0.25 plus 1.5 plus 0.25, which is just 2. And then the height we just found. Okay, so I'm going to put 2 here. All right, so we got 1/2 times 2.49 times 3.5. And then we're going to calculate that and see what we get. Okay, and we get 4.375 square feet. Okay, so the answer has to be B. All right, so let's look at the area of kites and rhombi. Okay, so in order to do the area, we need to actually know the diagonals. We need to actually break these up into diagonals, okay? So what we're gonna do, oops, let me put this back here. Okay, so the area, so you had to take the first diagonal, oops, we're gonna call the first diagonal D1, and the second diagonal D2, and you just multiply them. Okay, so D1 times D2. That's how you find the area, is to take the diagonals, and you take the product of the two diagonals. Okay, so again, you take the two diagonals, you multiply them, and then in this case, you're going to cut that in half. So we're going to show this formula right here, okay? So you get the area of a rhombus or kite, you take the two diagonals, you multiply them, and then you divide that by 2. And that's going to be your area, okay? So this is for both the rhombus and the kite. All right, so area of a rhombus. So find the area of the rhombus. So now we know that this is 7. So if that's 7, then that means this is 7, right? Because after all, a rhombus is a parallelogram, so it's the same on both sides. And if this is 6, then this is 6. And so we know what D1 is. This is the diagonal 1, and then this is diagonal 2, right? Let me get rid of this. So this right here is diagonal 2. And so diagonal 1 is just 6 plus 6, right? And diagonal 2 is just 7 plus 7. Okay, so we got one of the diagonals is 6 plus 6, the other one is 7 plus 7, and we just multiply them, right? So we got area equals 1/2 times diagonal 1 times diagonal 2. That's really all there is to it. Half of 12 is 6, and then you can do 6 times 14. So we'll do this on the calculator. 6 times 14, so you get 84. So it's got to be 84 millimeters squared. All right, and that's it. That's all there is to it. Go ahead and do the check and find the area of the rhombus below. All right, so here we go. We got the diagonal 1, which is 18, and then they gave us diagonal 2, which is 10. And so the area equals 1/2 times diagonal 1 times diagonal 2. So it's going to be half of 18 times 10, which is 90. So we got 90 meters squared. So the answer is B. Okay, so now let's do the area of the kite. So the area of a kite is the same formula. It's 1/2 times the two diagonals, 16 times 9. So it's going to be 1/2 times 16 times 9. Half of 16 is 8, and then 8 times 9 is 72. So the answer is 72. See how quickly we went through that? So go ahead and do the check below. All right, so this is D1, this is D2. So the area is 1/2 times D1 times D2. So just multiply them and then divide by 2. So you're going to get a decimal for this one. So you get 17 times 21 divided by 2. So you get 178.5 square meters. All right, so let's wrap the lesson up. We got one more page to go. So use area to find the missing measure. Okay, so it says one diagonal of a kite measures 55.88 centimeters, and we're looking for the measure of the other diagonal, which we'll call x. They say that the area is 92 square inches. What is the length of the other diagonal in inches rounded to the nearest tenth? Okay, well, first off, there's it says that 1 inch equals 2.54 centimeters. So we got to convert that. So we got to take 55.88 centimeters, and we need to divide that by 2.54 in order to convert it from centimeters to inches. Okay. So we're going to divide those. We get 55.88 divided by 2.54, and we get 22. So we get 22 inches exactly. All right, so now we know that's 22 inches. And remember that the area formula is 1/2 D1 D2, right? So we get A equals 1/2 D1 D2. And we know that A, they told us that the area is 92. And we just found D1 is 22. And so we just got to solve for D2. All right. We'll call D2x, I guess, because that's what they call it in the problem. And then half of 22 is 11. So really we got 99 equals 11x. So if I divide by 11, I get x equals 9. Oh, that's not 99, so 92. So we got to divide both sides by 11, and we get, and then that gives us x. Okay, and there is our answer. So x is 8.4. So the length of the diagonal is 8.4 inches. Okay, so you just have to be careful. They do give you unit conversions in the geometry formula sheet in the EOC, for the EOC, and so you have to make sure that if they give you area in square inches, that you got to make sure both dimensions are in inches, so on and so forth. So in this case, this is a good problem in which you have to be conscious of the units. All right, go ahead and take a look at the following problem and try it. Okay, so this problem is easier because you don't have to convert from centimeters to inches or anything like that. You just have to do the work. So if this is 7.3, then this is 7.3 over here. And so you know that we can combine those two to get the diagonal. We're going to call that diagonal 1. And so 7.3 plus 7.3. Which is 14.6, and that is AC. So we know that AC is 14.6. All right, and then now we're going to, and so we know that the area, they said that in this case, the area of the rhombus is 96. Okay, so the area formula is 1/2 times D1 D2, and we know that the area is 96 because they told us that. And D1 is 14.6, and we'll call D2 x. Actually, we'll just call it D2 because they're tricking you. This is x, and then this is x. So I'm just going to call it D2. All right. So then we're gonna do half of 14.6. Half of 14.6 is 7.3, and then we can divide by 7.3 on both sides to get D2. So we got 96 divided by 7.3 is 13.15. Okay, and they want us to round to the nearest tenth, so 13.2. All right, and then so if this is 13.2, or actually the entire diagonal is 13.2, so I should be careful here, okay? So the entire diagonal is 13.1507. But then if I divide that by 2, yeah, let me just round it to what I had before, 13.2. So that's going to be BD. So BD is about 13.2. Then I can divide this by 2 to get x, right? So that's what I'm going to do. So 13.15 divided by 2 is going to give me x, because we know that this whole thing is 13.15 or 13.2. So we get 13.15 divided by 2 is 6.575, which is about 6.6. Okay, so half of 13.2, 6.6. That makes sense. All right, that's going to do it for the video, guys. Hope you found this useful, and as usual, I'll see you in the next one.